Hello, cryosphere. The climate computer models have failed miserably, and the climate panel has also failed us miserably, sadly. There are many reasons why they have failed, but that is a topic for another video. So, what do? We know we have global warming, and we know that the ice is melting. And in a number of years or months, the Arctic Ocean will be ice free for maybe about a week, and we will have our first blue ocean event. Uh, a few years after that, we will likely have a full year of blue ocean, an entire year with very little sea ice. And why do we care about that? Well, firstly, among the very few people on this planet who actually have thought about that and said something about it, both of them say that the first year of no sea ice at all in the Arctic will most likely also mark the end of organized humanity, the end of civilization. So if they are right, think about it. We've been organized, living in communities in a so-called civilization for 10,000 years since the past ice age. And now, if the predictions and the theories are correct, it may only be a single digit number of years until the whole civilization thing is history, and people will start trying to make a living without cities and communities, at least bigger communities with lots of people, maybe smaller groups. So that is why we care about when we lose the sea ice. And in this video, I will go through a number of slides and explain what is on them and what they say about loss of sea ice. So, firstly, I don't talk about day-to-day, measurements of sea ice with daily numbers. I found it more practical for prediction purposes to make a 365-day average where you average the sea ice for a whole year, basically, because then you don't have the summer and winter seasons to think about. Okay, first slide. Maybe some of you have seen this because it's been posted quite a lot. This is a special plot that takes these annual volumes and bunches them into decades. And this is sea ice volume, so you can see all the decades since satellite measurements started in 1979. So you have the 1980s here and the 1990s, quite a big loss here, but an even bigger loss down to the 2000s. And the 2010s, of course, they are not finished. We are still here. We are in 2017, so we have 3 more years to go, and that is why you have on this side of the graph you have 8 years average, and on this side you only have 7 years average because you're not there yet, right? And down here you have this year, which is the lowest year for annual average ever in satellite history, and I also included the second lowest, 2013. So yeah, you can see 2013 going up during summer, but that's, as I said, it's because you have a 365-day average. So it can do whatever it wants, in summer, winter, whatever. So, yeah, lowest ever and going lower. And in the usual chart, we only have the individual years and not the decades. So you can recognize 2017, 2013, and then 2011 and 2012. These are the only years that are lower than 14,000 cubic kilometers. So all the other years are way above here, right? So we've now come down to 12.7 thousand cubic kilometers at the start of the month. And we've been going down all year. This graph has gone down all year, and I think, if I remember correctly, we've been like 8 or 9 months every day the 2017 or 2016 volume has been continuously lowest ever in the satellite record for volume. So that's a record in itself. Right, and now we are losing 23 cubic kilometers per week of the annual average, and this is a tempo that will lose us all the sea ice all year by April 2026. And we turn to the next slide. This is annual average extent, and different from the volume. You see it's going up, and now it's at 9.78 million square kilometers. But today, for the first time in a few months, it has plateaued out, and it's going to go down today for the first time in about 3 months, I think. Yeah. So you will see this graph turning down at some point here, and you can see the big October plunge in 2016 over here, which was astonishing. And you also have 2013 here, and the record year for annual average extent before last year was 2012. 2016 was the lowest ever year for annual extent, and but it still looks like 2017 will be even lower than the record year 2016. Okay, so this is the same chart, annual average extent but you have 14 years in the same plot. So we start with the 2004 here, and you have the same color for 5 years, 5 year cycles. There's some kind of repeating pattern, and people are discussing it. Is it a real thing, or is it just coincidence? In any case, you can see this is what 2017 has done till now. This is the entire 2017, and you know you can see the same date up here, and to me anyway, it looks like we are actually in a repeat of the 2007, 2012, 2017, and yeah, suffice to say, you see what the other years did, you know, after mid-July. Huge plunges here in the annual average extent, and both of these years were record low for the late autumn extent in September. So yeah, and it's also a bit scientifically exciting to see if we are actually going to have a repeat of the 5 year cycle this year. Okay, so because of a new way of calculating the predictions, I have reset this lag cloud. So now it starts the 1st of July, and all the other data in this cloud have been archived. You start anew, and the only thing you see here is the predictions from the volume chart and from the extent chart, latest one, and the extent graph was going up, so that means it never hits 0 for all year CIs. And on the volume side, you have the April 26 prediction for loss of all year ice, and the year 26 and the decade 2020s. So this will be more interesting in the coming weeks and months. And this is a table from my July contribution to the CIS prediction network, and it's basically annual average volume from biomass, and yeah, basically just you can stop the video and read the table for yourself and study it, but it basically shows that only in the very latest years we have come down to a situation where you have single digit predictions, linear predictions for when we may lose all the ice all year. And keep in mind what I said in the start of this video. If there is a link between full year loss of sea ice and loss of civilization, electricity, food deliveries, and water in the tap, this is something to pay attention to. 7 years is a short time. Okay, next slide. So one of the reasons that the climate panel, the IPCC, and the climate models have failed so miserably is that if you read their climate reports, you can read between the lines and you can see what kind of data they have, and they will almost always talk about the two-dimensional flat ice, the sea ice extent, and they will use the planet's worst resolution for satellite detection of sea ice extent, which is the American NSIDC. So it's a very low resolution graphic for determining how much two-dimensional ice you have. And yeah, this is the trend line for this NSIDC sea ice extent. Takes like 200 years to go down to zero, and just currently it's been going up, starting to go up. So it's a totally different situation from what you have in the Pyomas sea ice volume, where you have a graph that goes very steeply down, and which is also not flat, but you're losing ice in an exponential or faster than exponential way, and yeah, you have these different linear projections from the other slides that go down to somewhere in the 2020s, while the trend line for this full satellite series goes down to ice-free like in the first half of the 2030s. So yeah, I mean, people mostly are aware that the ice is melting in a 3D, three-dimensional way. It's the water is heating the ice and melting it from all sides in a three-dimensional body. So what you need to look at is how fast we lose thickness and volume, and not just the surface extent. Okay. Final slide. This is another plot to determine time of arrival for the winter blue ocean situation, and here you have longer trends, not only a week or month volume loss, but you have 3-year and 2-year and 1-year trends for loss of sea ice volume, and so they are sort of more stable and maybe more accurate, when they are consist of over 1,000 days of sea ice volume for the 3-year trend, and so they are bunched together here, and for the latest day here in July, you have everything from 25 to 2027 is when we will have almost no ice for the entire year in the Arctic sea ice, and this x-axis here is the development of these predictions, this linear projections since January, February, March, April, May, June, and July. It's like the 3-year trend is of course moving during this last half year. You have a new half year that is entered into the average loss, and you have a half year that is taken out of the average loss. So it's like a bigger loss over 3 years now than it was at the start of this year. You can also see the half year trend, which is currently at 2063, I included this as an indicator for which ways it's going, in the short term right now, and it's expected to come down again sometime during late summer or autumn, you and slowly bringing the other longer term trends down as well. So yeah, at the moment, doesn't look very good for human civilization. Maybe it ends in 2025 or 27 or somewhere around there. Maybe it lingers on for a decade or half a decade after we lose all the ice. It's very little research on that. The UN climate panel has done or said nothing about the loss of all year sea ice, nothing at all. So it's very much left on our own to figure out what's going to happen without a functioning climate panel and without a functioning United Nations. So it's up to you and me to find out how the future is going to be. Okay, bye.